In this video, I would like to review some key concepts that summarize our whole idea of graphing. What we're looking at here is how do we graph this equation. So in other words, you can almost look at it as how is the x and the y related to each other. So for example, what value of x can I plug into here such that when I multiply it by 3 and I subtract some value of y, I get out this 5. And the really cool thing about this is that when I grab these x and these y values that actually work for this equation, and if I plot them on a coordinate plane, they're going to actually form a line. That makes this a linear equation. So a couple of things I want to do here to solve this one. First, I'm going to solve for y. And I like solving for y. I think it's an easy way to actually see how this is going to unfold. So to do so, I'm going to subtract. Let me change my marker here. So subtract 3x from both sides. And then I end up with negative y equals negative 3x plus 5. And now I'm going to divide everything by a negative 1 and see how I distribute that division of a negative 1. So I end up with y is equal to a positive 3x minus 5. Now when I have this, I could set up a table of values. So I could end up making a table of values, and let's go over here. I'm going to change colors. Table of values, and I'm going to plug in some x values and see what I get out for some y. So let's say I plug in negative 1, 0, and 1. Well, when I plug in a negative 1, I get 3 times a negative 1 minus 5, which will end up giving me a negative 8. And when I plug in 0, I get 3 times 0 minus 5, which gives me a negative 5. And when I plug in 1, I get 3 times 1 minus 5, which gives me a negative 2. So my ordered pairs that work are negative 1, negative 8, 0, negative 5, and 1, negative 2. So let's plot this. If I put this on the coordinate plane, I end up with negative 1 and 1, 2, 3, 4, 5, 6, 7, 8, like way down here. And then 0, 5, 1, 2, 3, 4, 5 here. And then 1, negative 2 here. And here is my line. And you can see that it's going to keep going in this direction as well. Okay, but one of the things I wanted to point out is how does this connect with our idea of slope-intercept form? And when I solved for y, I got this in slope-intercept form. And when it's in slope-intercept form like this, I'm going to change the blue, I can pull out my slope and my y-intercept. So my y-intercept, which is represented by my b, is negative 5. And that means that's where it's crossing the y-axis. And it is. It's right here at negative 5. And my slope, represented by an m, is 3. And I like to write that as a fraction because a slope is rise over run. So that's 3 over 1. So if I were to start, going back to green here so it pops up, if I were to start at negative 5, I could rise 1, 2, 3, run 1. So you see a rise of 3, a run of 1, and that's where my next point would be, and then I would connect my line. So I want you to recognize that when I solved for y, and I got it in this slope-intercept form, there's two ways I could go about this. I could set up a table of values like I did right here. Let's add a little star. You got that idea? Or I could just look at it and say, okay, well, that's in slope-intercept form. So let's plot the intercept, the y-intercept, and then do the slope from there. And I can validate that those two, I can verify that they're both equivalent. They both produce the exact same line. Okay, I want to try some more examples. In this one, I got these two equations, and I want to graph them. But one thing I want you to notice, if I look at this, I can say, all right, this is a little strange because there's just an x. And over here, this is a little strange because there's just a y. So there's only one variable. So how does that work? So let's go ahead. Because there's no y to solve for, I'm going to solve for x. So I'm going to add 2, and I get 3x equals 12. And I divide by 3. And I get x equals 4. So what does that look on the coordinate plane? Well, on the coordinate plane, that means I have to have a line such that every x value is 4. So if I go over here and I say, okay, what kind of line would be the case where every x value is 4? Well, that would be a vertical line right here. So that means that whatever point I grab on this line, it's going to have the x coordinate of 4. So when you have something that does not have a y value and you solve it for x and you get x equals some value, you'll know that that's going to be a vertical line, meaning that all of the x coordinates have to be 4, which would be that vertical line. So let's see over here. Well, no x's. When I solve for y, I'm going to add 1. I get this 5y equals 15, and y is equal, when I divide by 5, I get y equals 3. All right, so I see there's no x coordinate, there's no x value, but there will be x coordinates. It's just what I'm concerned about is that I have to have a line where all of the y values are 3. And the only way that could happen is if I have a horizontal line. So I have a horizontal line right here, and notice on this horizontal line, no matter what point I grab on this horizontal line, that all the y values will be 3. All right, more examples. In this one, I want to find the x and the y-intercept. So one thing I need to know is for the x-intercept, I have to understand that the y value is 0. That is logical. In order for it to intercept the x-axis, the y value has to be 0. When I want to find the y-intercept, I know that the x value is 0, and that has to be the case because in order for it to intercept, in order for it to cross the x-axis, the y value, in order for it to cross the y-axis, the x value has to be 0. So I like to set it up like this. X-intercept, y equals 0, y-intercept, x equals 0. So let's go ahead and, well, here's my graph, but we got to solve this first. So if I plug 0 in for the y, that 8 times 0 is just 0. So I end up with this negative 4x equals 12. And when I divide both sides by negative 4, I get x equals negative 3. So what does that mean? It means that my line is going to cross at negative 3, 0. So 1, 2, 3, make my point. And over here, if x is equal to 0, so I'm going to plug in this 0 in for x, so negative 4 times 0, just 0, so that disappears. So I end up with 8y equals 12. Divide both sides by 8, and when I simplify that, I get y equals 3/2. So that means that this line is going to intercept the y-axis at 0, 3/2. So that's going to put me smack in the middle. And there's my line. So I see where, in this case, I graphed by finding the x-intercept when y equals 0, the y-intercept when x equals 0, and then I plot those points and connect them. Now, if I were to solve this original equation, for y and pulled out the slope and the y-intercept, which would have been the exact same as the 3/2, but then I would have a slope, and if I were to plot it, I would get the exact same line. So know that you're doing the exact same thing. It's just a different way of going about it. And in this case, we're investigating the x and the y-intercepts. All right, last question. All right, so are these lines parallel, perpendicular, or neither? For them to be parallel, when I look at their slopes, I'm going to see that their slopes are the same. So I'm going to say that slopes are same. But I'll notice that the y-intercepts are different, and the y-intercepts have to be different because otherwise, if the slopes are the same and the y-intercepts are the same, it's the exact same line. But all I want to look is if the y-intercepts are different, but I notice that the slopes are exactly the same, then the lines would have to be parallel. That makes sense because if the slopes are the same, that means the two lines are tilting exactly the same rise over run. So it would make sense that they would be parallel lines. For perpendicular, the slopes are going to be opposite reciprocals. Opposite reciprocals. So an example of that would be if I had 3/4 and a slope of -4/3. Those are opposite reciprocals, and those would be perpendicular lines. Anything else is going to be neither. So let's figure this out. So I need to find the slopes. I have to get this in y equals mx plus b, our slope-intercept form, so I could evaluate this. So subtract 2x, subtract 2x. I get this -5y equals -2x plus 10. Divide everything through by a -5, so I end up with y equals, it's going to be a positive 2 over 5, because a negative divided by a negative is a positive. So 2/5 x minus 2. All right, so, and what I want to do is I want to just highlight this right here. So that is my slope of 2/5. All right, so let's go to this one. I'm going to subtract 5x. 2y equals -5x plus 20. Divide by 2. And I get y equals -5/2 x plus 10. All right, I'm going to have, I notice immediately that the y-intercepts are different. So I know that I'm not going to have to deal with the same line. So looking at the slope, so I can see right here, I have a slope of 2/5 and a slope of -5/2. I see the slopes are opposite reciprocals of each other. So that tells me that my line is going to be, and let me change this, that these two lines are perpendicular. And they're perpendicular because their slopes are opposite reciprocals. Okay, well, I hope you enjoyed this video that just highlights some key concepts when it comes to graphing. And I hope that you found this information helpful. Thank you.